Hello, my name is Joe Schmidt, and today we'll be going over the skeletal system and its basic components. Osteology is the study of bones. Did you know that your bones are alive? You have over 206 bones in your body. Things you should know. The difference between a bone and a feature, the organization by location, the classification by shape of bones, the function of bones, and the basic structure of bones. So first things first, let's go over the difference between a bone and a feature. So here we have a picture of the bottom of a skull. So bones of the skull are things like the occipital bone here, the zygomatic bone, the maxilla, and perhaps we'd have the mandible here below, but it's not seen here. A feature is something like the foramen magnum seen here. That's the hull we see. So that's a feature. A bone would be the occipital bone. A feature would be something like the foramen magnum. Okay. Other examples of features would be things like a fossa, a process, a projection, or a protuberance. Let's look at another picture and see if we can clear this up. So here's a picture of a cervical vertebrae. This is the spinous process of the cervical vertebrae. The spinous process is the feature of the cervical vertebrae. If you were asked on a quiz to name the feature, this feature, number 1 of the cervical vertebrae, you would say the spinous process. If you were asked to name this bone, you would say cervical vertebrae. Okay. Now let's talk about organization by location. And by location, I mean the two groupings here, the axial skeleton and the appendicular skeleton. When we're talking about the axial skeleton, I mean the head and the trunk. And that includes the skull bones, which are the cranial bones, and the facial bones, and then the hyoid. The thoracic, which are the ribs and the sternum. The sternum is broken down into 3 parts. And then the vertebral column. The 7 cervical, the 12 thoracic, 5 lumbar, the fused sacral, and then the coccyx, which is usually about 4 fused bones. It fuses as we age. The appendicular skeleton is the appendages or our limbs. The pectoral girdle, which includes the scapula and the clavicle. The upper limbs, which includes the humerus, the radius, the ulna, the carpals, metacarpals, and phalanges. Then the pelvic girdle, which includes the right and left os coxae. And then the lower limbs. It's misspelled there, I apologize. The lower limbs, which includes the femurs, the patella, the tibia, the fibula, the tarsals, the metatarsals, and phalanges. Now, classification by shape. So that includes the short bones, flat bones, long bones, and irregular bones. So let's talk about the short bones first. We have a picture of a hand here, and the short bones would be the carpal bones seen here. So short bones are typically rock or cuboidal in shape. Other examples would be the patella or the tarsal bones of the ankle. So short bones here are seen at the carpals. Other examples would be the patella or the tarsal bones of the ankle. Now the flat bones can come in many different sizes and shapes. Here we see the sternum. And then this is a picture of the rib, and it is considered a flat bone. Now irregular bones we know can come in many different sizes and shapes. Here we see I think this is the left os coxae, and then the cervical vertebrae here. The atlas and this is both the atlas, superior and inferior view. So if this is the atlas, then this should be what? All right, C1, cervical 1. Other examples of irregular bones would be the vertebrae, other vertebrae, of course, and then the sphenoid, which is a cranial bone, and it looks sort of like a bat or a butterfly. So it's a cranial bone. Next is the long bones found in the limbs. Here's a picture of a humerus. Another example would be the femurs. And then in the hand, metacarpals and phalanges, also metatarsals, and then the phalanges of the foot. And then in addition, the clavicle is actually considered a long bone as well. The clavicle is considered a long bone as well. All right. So moving on, let's talk about the functions of bones. So one of the main functions of bones is to support and protect. The vertebrae helps support our body and helps us to stand upright. And the cranial case, the cranium, it helps to protect our brain. Body movement. The bones and joints work together with the muscles to enable us to walk, run, and jump. Blood cell formation. So blood cells are made in the ribs and the limbs and the spongy bone. And then also the storage of minerals and fats. Bones are the largest supply of calcium in the body. So bones are the largest supply of calcium in the body. So important to note the functions of the bones. Now let's talk about the basic structure of bones. Here we have a picture of a long bone. You can see the compact bone on the shaft, and then the more porous spongy bone here towards the end. In the long bone, spongy bone is found more towards the ends of bones. In short bones, it is found towards the center. So in short bones, spongy bone is found towards the center. So here's a picture of a long bone. Compact bone is found towards the shaft. Spongy bone is found more towards the end of long bones. As averse to short bones, where spongy bone is found more towards the center of the bone. Red marrow versus yellow marrow. So as we know, red marrow makes blood cells. Kids have more red marrow than adults do. As we age, most of our red marrow in our long bones turns to yellow marrow, which is a great storage for energy and fat. As we age, most of our red marrow is found in the axial skeleton, in certain areas of the axial skeleton. So this medullary cavity once had red marrow in it, but as we age, it eventually turns into yellow marrow and a storage for energy and fat. So again, red marrow versus yellow marrow. Red marrow makes red blood cells. Yellow marrow is storage of energy and fat. Now let's talk about the basic structural unit of bones, the osteon. So the osteon is a sort of reinforced structure. It's a tube within a tube. Sort of like the rings found within a tree. It helps to resist torsion. Here you can see the green structure is the lamella. So it's one ring, and then more rings, and then another ring. And then facing the other way are the cannuliculi. That's the blue structures. It provides even more strength. The yellow structures are the lacunae, which is sort of a cavity in which holds the osteocyte, which is the bone cell. So osteocyte is the bone cell held within the lacunae. And then, of course, the central canal. So this is the basic structural unit, osteon. And within that is another tube, within another tube. And as you can see, here's another osteon, and then another osteon, another osteon. So it makes bone quite strong. Okay. Another interesting thing to note is that in the embryonic stage, bone tissue actually starts off as hyaline cartilage. So in the embryonic phase, bone tissue actually starts off as hyaline cartilage. All right, so things you should know or have gathered from this video: the difference between a bone and a feature, the organization by location, as in the difference between the axial skeleton versus the appendicular skeleton, the classification by shape, the difference between the short bones, flat bones, irregular bones, and long bones, the function of bones, as in the support and protection, the body movement, the red blood cell formation, and so on, the basic structure of bones, as in the compact and spongy bone, and the basic structural unit, the osteon. Thank you. That concludes our overview of the skeletal system and its amazing 206 bones. I hope you've learned something today and will continue to advance in your studies.